In this video, I'll show you how to make two paths on this relief in Powermill. I have some ready relief in BMP here. We just take this for example. Drag it to ArtCam. Give it a size. I want width to be 200. Okay, and height to be 20. Okay. So we got this file of relief. Most BMP gives us a very rough results, so we need to smooth on them. Okay, now I give it another layer behind it. I draw an arc align those in Y and change the size to be 200, just same width as the workpiece, and the height to 25. Apply. Okay, put it aside and draw a straight line as this. Make sure it's longer than the workpiece and put it to the center of the page. Okay, now extrude, use as center line, select, and turn off the relief. Calculate. Okay, so we got it down like this, and now I do relief, create triangle mesh. Okay, save triangles. Save as the Delcam machining triangle. Okay, we import model. Close the triangles. Okay. We define the workpiece based on the global transform, the white one here. Calculate, accept, and then create a work plane. Make it on top surface of the workpiece. Activate it. As we will work on wood, so we can make the speed faster. Now we define the rapid move height. It's called save Z. It should be depend on the work plane, so calculate it here. Start point. Okay, and now we create a new tool. End mill 6 number 1, 2 flutes, shank, give it a shank, holder. Okay, we do a model area clearance. Okay, I got this dialog. It's pretty high. Any step over, step down, the links straight. Okay, calculate. It will take a very long time, so we just wait. Okay, it's finished. We can see the 2 paths created. Okay, and we can shade the tool to make it more visible. Okay, you can do a simulation as this. Okay, we save it here, and now we create a bore nose to do the finishing work, and we need a smaller tool to get more details, so it's 3mm, and with a tool with 20 of blade. Okay, the holder. Okay, so I create a raster finishing with these two. Give it two-way, step over 0.2. Let's make it a bit bigger to get a faster simulation and then we'll check this later. Okay, and links straight. Okay, just calculate, and it will be faster than the roughing work. Okay, so I to pass simulate here. Okay, so you can see how it goes, like a scanning. See here, when it work on the border, the lowest point of this work, your spindle, the holder may crash on the material. So we need to do something to avoid this. We may use a longer cutting bit, but that will make a long cutting bit is more easier to be damaged, and a longer one is losing the accuracy, so it's better to use a 4-axis machine. Okay, so we need to optimize the 2 paths here. Do setting, finish, and then we give it a more reasonable step over value, and the key point is here, the 2 axis. The default setting is the vertical, so the spindle you're cutting to is always vertical to the plane of your work plane. Now we change it to towards line, and we define line to make it parallel with the y-axis. So here I change the direction, and also I make it in the center of the x-axis, so it's 100 of x and minus 100 maybe. Let's show it here. See, it's just a straight line as this. It's parallel with the y-axis, and it's just in the middle of the x, so it's middle of your workpiece. I think I make it lower. Okay, seems good. Now we calculate it again. Okay, so now 2 paths simulate from nearest point. And you can see now it will not crash on the workpiece anymore. So it's more safe to work in this way, and you can just use a short cutting bit is enough. You needn't to use a very long cutting tool. Okay, so we do the simulation to make it more clearly. This is the roughing work. Make it faster. Okay. Now we see the finished work. We activate these two paths. If I slow it down, you can see how it worked. Okay, just make it fast. Okay, so it finished. Like this. Okay, with the help of Powermill, we can generate 4-axis and 5-axis two paths according to your sense router to optimize the two paths to make your work more efficient and save you more time. Okay, thank you for watching. Bye.